Hi again. This is talking about your paper, part two, because I ran out of space on the computer hard drive for all the videos that I've been doing. So hopefully this works. This is the paper project template link that you have on Canvas. And so if we look at our Canvas, we'll see it right here, paper project template. And again, look at the sample papers because those will give you an idea. Even if you don't understand the science behind the paper, you can see how they're discussing or talking about things. So in terms of our paper here, it's actually due March 4th. Okay, so let's put that in there at midnight. And that is 1 week from when our poster is due, so it gives us some more time to do our papers. But you're going to have your abstract, and again, your abstract needs to be about 200 to 300 words, and you need to include both the Spec 20 and the back titration into your abstract now. Okay, and then of course, do not assume that the reader is familiar with your samples or your methods, and be very general again. Don't be saying specific amounts like grams or milliliters of your samples, let's say for back titration. If you say the method back titration, we're all going to understand what you're talking about. Do indicate that it is with sodium hydroxide and hydrochloric acid. You don't have to have the specific molarities though. And talk about how you're determining the percent aspirin in the sample, and then by default the percent salicylic acid. You also want to look at talking about the ages of your samples versus the amount of salicylic acid using both your methods, and then comparing your results to Mary's class also to determine how well your method may have worked. Now your introduction, you've already written an introduction for your Spec 20, but you do want to write, include into that introduction your back titration method. And again, it gives context to your work. You're not going to discuss your method in detail, just an overview. And again, it should probably be a couple paragraphs, because one paragraph will be about the Spec 20 and visible spectroscopy versus the back titration technique. Okay, now the methods, this is detailed, okay, and think methods, not procedures. We don't want specific pipettes, but you do want to go into, you're making up 5 standards. You are using the Spec 20 to produce a calibration curve. Okay, you didn't say that in the abstract, but you're going to say it here. And so then I'm looking at the absorbances of the salicylic acid samples, or excuse me, the aspirin samples, or the salicylic acid standards of known concentrations. You can determine the concentration of salicylic acid in your unknown aspirin samples of various ages. Okay, and so that's not going into detail, but it is saying essentially how you're doing this experiment. You're going to make a calibration curve, and you're going to find the concentrations using that equation of the line from the calibration curve to find unknown concentrations in samples. Okay, you also want to talk about back titration. And so you'll titrate sodium hydroxide, or excuse me, titrate HCl with a standardized sodium hydroxide solution in order to standardize hydrochloric acid. Okay, so I'm again not going into specifics about how many milliliters or anything like that. And then you can say, all right, I've done that. And then I'm going to take 3 identical aspirin samples. I'm going to weigh out an amount. You don't even have to say the amount though. Say out a known quantity of aspirin into 3 Erlenmeyer flasks. You don't even have to say the size. And you're going to titrate that with the standardized sodium hydroxide to the first endpoint. Okay, and this will then be the point at which you have made the aspirin -1 ion. And then you can go on to talk about how then you will put your aspirin samples into a hot water bath. You don't have to be specific about the temperature, but you'll put it in a hot water bath so that you can speed up the second hydrolysis reaction in which the aspirin -1 ion is now turned into the salicylate ion. Okay, and after that, in which you will back titrate using your now standardized hydrochloric acid solution to a colorless endpoint. Okay, and you want to do say something that your indicator is phenolphthalein. Okay, somewhere in there. So basically, you have not gone into how many and how big your sample sizes are, but someone would be able to read this and say, hey, this is how we would do this. Okay, so you don't need a specific mass of your aspirin samples. You might want to say that your sodium hydroxide is approximately 0.1 molar, and that your hydrochloric acid, when you standardize it, should come out to be roughly 0.1 molar. Again, we don't need exact numbers here, though, because this is just a method. So someone can, in reading your paper, make up their own lab. Okay, and I did do this for this back titration. I read someone's paper. They didn't give me specific pipettes of samples or anything like that. I had to make that up. But I did understand how basically they did their experiment by back titration. They had to use a hot water bath, speed up the reaction, that type of thing. Okay, again, no specific grams here, no specific milliliters. Now, you do want to say, if you used a stir to, stir the solution, fine. If not, most people, just swirled it. You don't even have to say that then. We know how you're titrating. Okay? Actually, don't even put the stirrer in there. Forget about that. Now, in terms of sample preparation, your aspirin samples did need to be dissolved in ethanol. You do not need to be specific about how many milliliters of ethanol. Just say you dissolved it in ethanol and you diluted that with some water and you titrated it. Okay? Again, no specific numbers in your method section. Okay? Now, in terms of subheaders, then what you may do is you might want to say spec 20 method, back titration method, because you use multiple methods in this study. Now, the results section, okay, it's going to be a text summary of your results. Okay, so basically, what were you able to conclude from your data? Right now, I know from last week, we cannot conclude that the age of the sample directly relates to the percent of salicylic acid in the sample, at least using the spec 20. Okay, so that's something you could say right off the bat. And then you can present your data in table form. Now this is your section in which you want to not include raw data. So I don't want initial milliliters of sodium hydroxide, final milliliters of sodium hydroxide. I don't need that stuff. What I do need is I need to know, like, let's say your mean percent salicylic acid from the spec 20 versus, its sample, age or what have you. You also want to have like standard deviation. You want to do the same thing for your back titration. What percentage of salicylic acid did you determine, and what was your sample age in that section also? Okay. Now, essentially, you will also be answering any questions like, is there a relationship between age and the percent salicylic acid? Or is there zero correlation there? Also, because in your introduction and abstract, you are comparing two different methods on their viability of how well they will work to determine the percent of salicylic acid, you need to compare the differences then. So that could be a percent difference between the salicylic acid determined by spec 20 versus the percent salicylic acid determined by back titration. And remember, percent difference is the same as percent error. Okay? And so you could calculate that and say, what is the differences? Okay? And then what you can do, and that can be from your mean value for each of the methods, talking about which method maybe is better. Okay, compare your answers with Mary's team also, because you'll also want to be discussing how viable your methods are with how your group did it. Okay, do your answers agree with Mary's group? If they don't, Was it because maybe you guys did the method wrong, they did the method wrong, or is the method just internally flawed? Okay. Now, you do want to let a caption, okay, help the reader determine what a graph is about. So even though it has a title, okay, within your paper, you do want to insert graphs that have captions at the bottom and say, according to this graph, there is no correlation between the age of the sample and the percent salicylic acid in the sample using the Spec 20. So you have summarized up what that graph is saying to you. You can't just assume that someone knows how to read a graph and get viable information from it. You kind of have to tell them the story. Now, make sure, of course, your graphs are properly labeled and they have units and an actual title. Okay? Now, we are not going to be having graphs that typically have multiple sets of data. And if they do, like let's say, for example, you're going to put on the same graph Mary's class data versus your class data in terms of your particular sample, you do want a legend saying, the purple dot or, the shaded X is Mary's data for her class with that, term. That term like fall 2012 or something, and yours is the open circle or whatever, but it will say that in the legend. And of course, in the text section, your little caption, refer to that. Say, Mary's class data is with the X's, my class data is with the O's, and this is what you have. Okay? And in the discussion, this is the most, other than the abstract, I think it's pretty difficult to write a discussion because you need a thoughtful reflection. You need to discuss your error. You need to say what happens to your end results due to this error. Okay? So are there any limitations to your interpretations? For example, the decomposition of salicylic acid, it decomposes into acetic acid also. Will that acetic acid being around inside that beaker require more or less sodium hydroxide to titrate to endpoint? Will it require more or less hydrochloric acid to back titrate? And if so, if those numbers are higher or lower, you're going to have to determine what that is. Will that make your percent salicylic acid higher than it should be or lower than it should be, especially for back titration? Okay, don't use any vague language like things like this is fairly pure. Okay, unless you got a number to back it up, don't talk about it. So again, if you're saying one method is better than the other, don't say one method is better than the other. You have to say it is percent, difference by these two methods, and comparing with Mary's class, it was percent, difference by, these two methods. I think my method's better because of blah, whatever. Any implications? Why would anyone care about our results? Okay, first of all, in future, do we want to use both of these methods again to analyze salicylic acid? Are they reliable or are they not reliable? Okay, do we want to use Chem 120 samples anymore? Probably not, but you do want to say something about that. How reliable is it for them to have synthesized pure salicylic acid samples? Okay, any difficulties? Of course, if in lab you realize that you could not titrate to the same end color point every single time, that's an error. What does it do to your percent salicylic acid results? Okay, what improvements might be made next time? Maybe, who knows? Maybe you want bigger, smaller sample sizes, have the Chem 121 recrystallize before using. What do you want? Okay, and so it should just be a short paragraph. Okay, now you have to kind of sum up stuff. So we don't want a huge list of errors, but any error that you do have, what does it do to your final result? And then, of course, just a quick reflection upon your results. Okay, what was limiting you in lab? And it can't just be quote unquote human error. And then, of course, the literature cited. And so if you're using anything from the internet, please cite the complete internet address here. And then each person is submitting their own paper. And so you can collaborate, of course, on any data because we all should have the same data, but you need to write your paper individually. It will be typed double-spaced, and you're going to save it as a PDF format. Okay? And actually, I would prefer a Word format if at all possible. And so if you have the ability to save it as a doc format, that would be awesome. But I can use PDF if I want, okay? You're going to print out your paper and print out the 142 paper rubric paper and staple it to the back of your paper and give me your paper. And you're also going to email me this document as an attachment because, again, I'm going to run it through the lovely, lovely plagiarism program so that you are not, unless you directly quote something from the internet and give it kudos in the citation, you should not be copying things from the internet, okay? Now, in terms of spelling and grammar, you need to proofread this thing. Late papers lose 10 points a day, okay? And I have a spelling error. So you need to cite your sources and, of course, plagiarism. And if a student is plagiarizing a paper, basically cutting and pasting from the internet, and it has been found that a student does do that, we do record or report incidents of academic dishonesty to the Dean of Students. And so your name goes on a master list, and we can track that through your entire college history. And so all other instructors that you'll ever take from could see that you did plagiarize a paper. So please be very aware of not cutting and pasting from the internet. Now, hopefully this gives you a general idea of how I would like the paper to be done. And so hopefully your paper is totally awesome because I totally expect it to be. Now, if there are any questions, please see me during any of my office hours. But remember, plan ahead because there are only a certain number of hours that I'm at on campus because I have a lot of teaching this term and everyone's really busy, so am I. And so let's just be aware of that. I will help anybody as much as I can, so please stop by my office. All right, thanks a lot for listening. This is it.